Now dear student, we are going to discuss this question. This is 1.6. In this question it is given to you 4 point charges QA, QB, QC and QD are located at corners of a square ABCD of side 10 cm. Okay, fine. What is the force that is exerted on 1 microcoulomb placed at the center of a square? Clear? So now we are going to solve this question. Concentrate on a screen. Now let's suppose first I am drawing here a square. Let's suppose this is square. Yes. So let's suppose this is square and we can say 4 point charges are placed at the corners of a square ABCD. So let's suppose I am saying this is A, B, C and D. Clear? And let's suppose we place here 4 point charges. So let's suppose here we have this charge 1, this is 2, this is number 3 and here we are having charge number 4. Clear? It is also given value of QA, QB, QC and QD we know. So value of QA, this is given to you in this question 2 microcoulomb. Clear? Same here, value of QB, this is given to you minus 5 microcoulomb. Okay, fine. Value of QC, this is given to you 2 microcoulomb. Clear? And value of QD, this is given to you minus 5 microcoulomb. Clear to everyone? Now listen carefully. One more point is given to you, side is having 10 centimeter. So this is given to you 10 centimeter. Clear to you? Okay, fine. Now what is force? This is acting on a charge of 1 microcoulomb. This is placed at the center of square. So let's suppose I am placing here a charge. Let's suppose this is a charge and this charge is placed at the center of this square. Clear? And let's suppose if we find here distance between these two charges, how can we find? Clear? So we can say, let's suppose we can say ABCD and let's suppose this charge is E. Clear? And we know charge, this is also given to you, this is 1 microcoulomb. Clear? Objective is what? Our objective in this question is to calculate the net force this is acting on this charge. Clear? So first I am drawing here the direction of our forces. Clear? So now concentrate. First we can say this A charge, we can say QA, this QA we have positive and this E, or we can say charge QE, this is 1 microcoulomb. I can write like this, this is 1 microcoulomb, this is also positive. Clear? So from here you can see, we can write the direction of forces like this. We can say here force this is acting on E by A. Clear to you? Yes or no? Now you can also see like this, because this is 2 microcoulomb and this is 1 microcoulomb. Yes, so we can say here this force is acting, this is F, this is acting on E by C. Clear? Now you can also see here we are having negative charge and attractive force that is exerted on the charge E. Yes or no? So we can write like this, force this will act in this direction F, E and this is with respect to B. Clear? Now we can also write like this, this is also minus, so we can write like this, force is acting in this direction and this is force acting on E with respect to D or by D. Yes or no? So now if we find here magnitude. Clear? So first we will write here magnitude and then let's see in which direction or what is the net force this is acting on a charge E. Clear to everyone? So now concentrate. Now listen. If we write here first FEA, clear? So we can write like this FEA. Let's suppose I am assuming this distance is R, this is R, clear? Every distance we have R, clear? So we can write like this K, clear? Here we can say this is QE, clear? Multiply we have QA and this is divided by R square. Yes or no? Now we can also write like this F. We can say F, this is EC. Clear? We can write like this Q, KQE. Here we can say QC divided by R square. Clear? Now we can write like this F. We can say EB. This should be equal to K, QE. We can say this is QB divided by R square. Clear? Here we can write like this FED. This should be equal to K. This is QE. This is QD divided by R square. Clear to everyone? Yes or no? So from here you can see in every term we are getting one term common, KQE upon R square. Clear? And here we have this is QA. Yes or no? Then we can write like this here. This is also QE over R square and this is QC. Clear? We can also see like this KQE upon R square and here we are having this is QB. Clear? And this is KQE over R square and this is QD. Now listen carefully. Actually we can put here all the values of KQE upon R square. Clear? But first we will try to analyze that actually what is the forces, what is the magnitude of the different forces this is acting on the charge E. Yes or no? So now you can see if we talk about A, we have charge 2 microcoulomb. So we can write like this KQE upon R square and this is multiply because 2 microcoulomb we have, so 2 into 10 to the power minus 6. Clear? Now you can say here we are talking about FEA. So first we observe what is the force this is acting FEC. Clear? So if we talk about FEC, this is KQE upon R square. Now charge Q at point C, this is given 2 microcoulomb. So we can say 2 into 10 to the power minus 6. Now listen carefully. If we talk about force FEA and FEC, both are having same in magnitude but acting in an opposite direction. So what is net force this is acting on this charge E due to these two forces, that is 0. Yes or no? Because both forces are acting in opposite direction but having same magnitude. You can say like this. Because both are having same magnitude, so net force due to these two charges is 0. Yes or no? Now let's check what is the force this is acting by ED. Clear? So for the ED, we can say, we can write like this. This is KQE upon R square and then we can write this is 5 into 10 to the power minus 6. Direction we have already considered, so no need to write. Clear? Or if you write, then you have to write all the forces in a vector form. Clear? So now we can also write like this. This is KQE upon R square. Now what is charge due to B point? We can say this is minus 5 microcoulomb. So we can say 5 into 10 to the power minus 6. Clear? Now you can clearly see FEB and FED both are having same in magnitude but opposite in direction. Yes or no? So we can say again net forces by these two charges is again 0. Yes or no? So we can say, sir, what is the net force this is acting on a charge that is placed on the center of this square? We can say net force is 0. Yes or no? So finally I can write like this. I can write like this. Net force this is acting on a charge that is placed on a center, this is 0. Yes or no? You can also find this same expression in a vector form also. Clear? But it is always better if you consider first the direction logically and then if you solve for the magnitude and just compare. If you are getting the net force, then you have to apply the law of parallelogram addition and after that you can get net force. Clear? But here you can see in this condition we are getting equal and opposite forces. So net force we can say this is equal to 0. Clear? So what is the answer of this question? We can say correct answer we have 0 Newton. Clear?